This is a video on work. The question states, find the work done by the force field F of xy is equal to 1 plus y times I plus 2 plus x times j along the circle of radius 2 centered at the point 3, negative 1 on a particle moving clockwise. So let's sketch the curve. We have a circle. The particle is moving clockwise. The center of the circle is 3, negative 1, and the radius is 2. So let's parameterize this circle. And the way to parameterize a circle is we remember polar coordinates. So typically, the polar coordinates are that x is equal to r cosine of t or theta. R is 2. And since we're going clockwise instead of counterclockwise, we get 2 cosine of negative t. The clockwise tells us that we go opposite direction, so we get negative t. We're centered with x equal 3, so we need to shift by 3, and that's why it's 3 plus 2 cosine of negative t, and then times I. Y is typically r sine of the angle, but since we're going clockwise, we have 2 for r times the sine of negative t, and we're shifting down 1 because the center of the circle has y-coordinate negative 1, so I get negative 1 plus 2 sine of negative t, and then times j. And t is the angle, so it goes between 0 and 2 pi. So let's simplify this a bit. We recall that the cosine is an even function, so cosine of negative t is equal to cosine of t. And the sine is an odd function, so sine of negative t is equal to negative sine of t. So now let's find the derivative r prime. So I take a derivative. The derivative of 3 is 0. The derivative of 2 cosine of t is negative 2 sine of t. I still have the I. And the derivative of negative 1 is 0. And the derivative of negative 2 sine of t is negative 2 cosine of t. And I still have the j. So let's recall that the work done by a particle against a force field, F, is defined by the integral from a to b of f of x of t, y of t, dotted with r prime of t, dt. So now we substitute in. We have our f is 1 plus yi, and y is negative 1 minus 2 sine of t. So we get 1 plus negative 1 minus 2 sine of t. That's the I component. And then we have 2 plus x, and x is 3 plus 2 cosine t. So we get 2 plus 3 plus 2 cosine t. That's the j component. And then we dot it with r prime of t, which is negative 2 sine of t, comma negative 2 cosine of t. Then we have dt. So we can simplify this. The 1 plus negative 1 goes away as a 0, and 2 plus 3 is 5. And then I could take a dot product, and what I get when I take a dot product, we have negative 2 sine t times negative 2 sine t is 4 sine squared of t. And then we have 5 times negative 2 cosine of t is minus 10 cosine t. And then we have 2 times cosine of t times negative 2 times cosine t is minus 4 cosine squared t. So I integrate that from 0 to 2 pi dt. So I could do this by hand or by calculator, and either way, what I got was that the work done by the force field F of a particle moving clockwise along this circle is equal to 0. And I'm done with the problem.